Right. Good evening, guys.
Hey there.
You hear me okay?
I hear you okay. Has John
Yes.
figured out his keyboard yet?
I don't know. John had a major power crisis that yeah.
Yeah, still working on it.
Oh, there you
Okay.
go. Oh, there he is. Ha! So,
Yeah.
well, welcome astronomers and science fans. And I'm Rich Ozer. I'm here with Gerald McKeegan and John Curry. Once again for our virtual astronomy program. Of course, it's completely clouded out in the Bay Area, but we're here at the Chabot Space and Science Center, and I am sitting in front of our 36-inch reflecting telescope, and he's Nellie is waving to you, and she did it all by herself. Um, the Chabot Space and Science Center is presenting virtual programs throughout the week, every week. And although the center is closed, we are trying very hard to keep everyone engaged in science education and astronomy education. And we can certainly use your support. So if you're on Facebook tonight, note that there's a donate button. And we would encourage you, if you are able, to donate to the Chabot Space and Science Center. We hope to be open in November, and with all kinds of interesting new exhibits and new relationships. Which maybe Gerald, you want to mention our new relationship with NASA?
Yeah. So Chabot Space and Science Center and NASA Ames Research Center are about to become partners. Chabot Space and Science Center will act as a visitor center and a research I'm not sure what the word I should use is, a center to highlight some of the research that's being done at Ames Research Center. And Ames Research Center will help Chabot with a lot of our programming and our exhibits. Also, we will join forces with them to do some outreach to the local communities, to the schools, and what we call our virtual learning center. So it's a really exciting opportunity for both Chabot and for Ames Research Center to kind of broaden our horizons and broaden our outreach to the community here. So we're really looking forward to that. And that was just announced here last week, and we are going to be having a grand opening in November, like Richard said, and NASA and Chabot will have a kind of combined grand opening ceremony for the NASA Visitor Center and uh, and Chabot Space and Science Center, all in one location.
Great, thanks for that.
Sure.
As we often do when things are cloudy or we're too humid here in Oakland, we'll present some of the astronomy news of the week or of the month, and so we have some presentations for you tonight. Um, where should we start? Do you want to start with Mars? We'll take the lowest.
Mars,
We'll take
yeah,
the one of the
yeah.
lower objects in the sky right
Sure.
now.
So, believe it or not, Mars is still in our night sky, even
Yeah.
though Mars reached what we call opposition last October, because Mars orbits the sun almost as fast as the Earth does. It's still in our night sky, and it'll stay in the night sky for another month or so. Uh, but we've had a rover on Mars, a new rover on Mars, Perseverance rover, and I think many of you know that Perseverance brought along a stowaway, a helicopter, a little helicopter that was attached to the bottom of the Perseverance rover, and that helicopter detached from the rover a couple of weeks ago, and the rover then moved away from it. And last week, the helicopter flew. So I've got a couple of things to show you about that. So I'll share my screen here. Um, Maybe. Let's see. Start out with which one? This one. So here you see the helicopter. This is a animated GIF showing the helicopter detaching itself from the rover, and then it's off by itself. So once it detached from the rover backed away from it, and it was sitting out there all by itself. And I'll stop that share, and then we'll go to a YouTube page. I'll try one more time here if I can find it. There it is. And we'll go full screen here, and you'll see the helicopter. You can see the rotors spinning down there. It's at the bottom of the screen. You can see the rotor spinning, and the helicopter rises up, hovers for about 30 seconds or so, 10 feet off the ground, and eventually it will settle back down to the ground. And this was the first flight that it made, just basically, can it fly? Uh, Doing this is not easy. The rotors have to spin at an extremely high rate. They're about 4 feet in diameter. There's two sets of rotors. They're spinning in opposite directions. And spins at a very high speed because the atmosphere on Mars is so thin. The atmosphere on Mars is about 1/100th the density of the atmosphere on Earth. So there's not a whole lot of air for those rotors to bite into. So they were 90% sure that they could fly, but not 100% sure that they could fly. They did some testing on Earth with the helicopter in a vacuum chamber, which is where they test satellites in vacuum chambers to simulate space. So they simulated the Mars very low density atmosphere in a vacuum chamber and flew several prototypes of the helicopter. In fact, it's too much trouble to show it to you, but there's actually some video on YouTube showing some of the test flights that they did in the vacuum chamber. And the first few test flights were not very successful. The helicopter was not very stable in flight. It kind of bounced all over the place, and it took several tries and several modifications before they finally got it to where it would fly consistently. So that flight that you just saw is the first controlled power flight of an aircraft on another planet. So it's a little bit of history that you just saw there. And of course, this paves the way for future missions where more robust helicopters can actually fly and cruise around a lander so that we get a much broader view of what's going on Mars, what things look like, and improve our ability to explore the planet.
A couple things to realize about this is because of the time delay in getting data to and from Mars, these are all automated sequences that are programmed into the helicopter or drone, whatever you want to call it, in advance, and then they set the time for when it's going to occur and watch the video and read the telemetry long after the fact. So these images came back many minutes later, if not hours in some cases.
The turnaround time I believe is 32 minutes.
Yeah, and it's also in order to make the coding and the software a little more nimble than the usual rover systems that are sent to Mars. It's the first time Linux is on Mars. So for those of you who are taking an IT perspective on this whole thing, we have Linux on Mars. I don't know which flavor of Linux it is, though. It's actually something I need to find out just for my own edification. Yeah, I don't know. yeah, Red Hat would be good because of the red. Yeah, Mars is red, so maybe it's Red Hat. I actually doubt it's Red Hat, but anyway, I'll try to find that out for a future talk on this.
In the meantime, Mario asked if the NASA Center is going to add construction to Chabot. Or is it just internal changes? It's kind of both. There's no new building being added or anything like that, but there will be construction done inside the current Chabot buildings.
Yeah, there's, one of the things we're going to be doing is bringing some artifacts over from NASA, and so we're reconfiguring some of our exhibit spaces to accommodate those. There will also be activities that will be developed jointly with NASA, and some of the exhibit spaces will be reconfigured for those. So there is going to be construction going on at Chabot, but it won't be, building new buildings or anything like that. It'll just be reconfiguring the interior to accommodate all this new activity.
I'm intrigued by the notion of artifacts coming over from Ames. Yeah, I wonder what that'll be, and I doubt it will be the centrifuge. That would require a much larger building, I think, that we've got. But
yeah, some of it involves the moon. NASA Ames Research Center is involved with the current Artemis program to go to the moon. So some of what they're going to bring over here is actually related to NASA's work on, the upcoming moon missions.
Oh, interesting. Have you ever seen the centrifuge in the centrifuge building in at Ames?
I've been in the centrifuge building and the wind tunnel buildings. Yeah, I've seen quite a bit down there.
Do you know that after they stopped training astronauts in that centrifuge, UC Davis borrowed it for a while for doing soil compaction studies?
Oh, yeah.
And they would fill the centrifuge with dirt instead of putting an astronaut in there, and then spin it around and see the degree to which different types of soils compacted. So anyway, that's a little bit of trivia about that centrifuge. I don't think we'll be seeing any centrifuge rides here at Chabot anytime soon, though. All right, what's next? Hey, maybe that would be fun.
Bob asked if there are any loans of equipment to attach to the telescopes.
Oh, wow.
So. I don't know that NASA does a lot with optical stuff and or at least with telescopes. So probably not.
Yeah, I don't think we're going to get the extra mirrors left over from the James Webb Space Telescope.
right. Yeah. We could get parts made out of beryllium or something.
Right.
So there's another event that happened. In fact, just kind of culminated just this morning. SpaceX launched another Crew Dragon to the International Space Station. 4 astronauts took off yesterday, I guess it was, and they arrived at the space station early this morning and joined the 7 other astronauts who are already on the space station. So right now, the space station has the largest crew that I think they've ever had. There's 11 people on board the space station right now. And what was interesting is the Crew Dragon that was flown was the Endeavour, which is the same Crew Dragon that made the first flight to the space station back last year. And also the launch vehicle, the Falcon 9 launch vehicle, was also a previously used launch vehicle. So this was a really good example of the SpaceX philosophy of reusing hardware and saving money in the process. So I do have an image to share, just a quickie one here. This is the SpaceX Crew Dragon as it was getting ready to dock with the space station. So you see it approaching there. If you ever watch the docking process, bring coffee because it's a extremely slow process. They have to approach at a very, very slow rate. So you could grow a beard waiting for the Crew Dragon.
You don't want any dents. They're more strict than Enterprise rent-a-car.
Well, not only that, but if their relative velocities are too great, they will drift into different orbits. So
right.
Be very slow about doing that. So anyway, that's another great.
That's a great photograph. I love that photograph.
Yeah.
All right.
Yeah, we have a good question on Facebook from Mike Bowen, who asks, it seems that the dust on Mars would be difficult to account for. The bearings on the motor and rotors are sensitive to fine grit. Is this part of the reason that the life of that helicopter is expected to be so short?
That may be one of the reasons, yes. Also, the helicopter doesn't have a lot of power. It's got a couple of little solar cells on top that if you if we went back and looked at it, you'd see a little square platform at the very top of the rotor shaft. And I think there's 4 solar cells there. So they're just enough to kind of charge up the batteries. And in fact, they had originally planned to fly earlier, but it actually took longer to charge the batteries than they anticipated. So, it doesn't have a lot of battery life. This thing wasn't
Oh yeah.
designed to be up there for a long period of time, and I'm sure dust is going to be a factor. But there's dust on Earth too, and we have a lot more dust. In reality, it looks like there's a lot of dust up on Mars, but
Well,
in reality, the atmosphere is
the dust on Earth is eroded by moisture, and on Mars less so. So
it's much
it's
grittier.
sharper
Yes.
and grittier.
Yeah.
So it's like
Yeah.
the moon, and
Yeah.
that's a problem for equipment and for
Right.
biology.
Right.
A couple good questions on ISS too. There's one. Have all of the astronauts on board the ISS been fully vaccinated for COVID-19?
Well, yes.
I suspect they have. Yeah.
They were vaccinated and quarantined. So
Yeah.
I don't know if you saw the video when the astronauts actually came out of the Crew Dragon and entered into the space station, and all the astronauts who were already there were standing there or hovering there waiting for them, and they're all hugging and getting really close and everything. There was no social distancing going on at all, and that's because they were all tested, they were all vaccinated, and they all had to quarantine before they went up there. So yeah, they're good. Of course, the astronauts that have been up there for all this time, if they were going to get COVID, they would have got it a long time ago. So
Yeah.
Dave asked a pretty good question though. Do they have enough vehicles to return all the astronauts in a case of emergency? I kind of doubt it. That would
Actually,
only fit
No, they do.
No,
they have
actually,
they have
they
the
do.
Soyuz. They have the Soyuz still.
There's a Soyuz which can take
Yeah.
3. There is another Crew Dragon that's just currently docked there. So yes, they do.
Oh, okay.
So
I think that is always a minimum requirement.
right.
I don't think they've ever been without enough escape vehicles.
Right. All right. Well, that's about all I have for space current events.
All right, I got a couple of things. I'll give you a break here, and let's see if I can share my screen here. Oh, okay, here we go. I wanted to share this photograph. Throughout our programs here, I've always talked about Damian Peach, a really well-renowned astrophotographer who is really well known for his images of Jupiter and Saturn. And I was not aware he also spent a fair amount of time doing photographs of the moon. In fact, he has a whole collection of lunar photographs, which I discovered today. And actually, many of them are published in Bob Garfinkel's book as well, in Luna Cognita. And this is a recent photograph that he took of the crater Clavius. And what's special about this one is he caught the very tops of the peaks of the not only of the main Clavius impact crater, but also the 2 smaller craters that are inside. And the sun was just in the right position. And Clavius, I mean, this is a pretty good-sized crater, right? It's 144 miles wide, and
it's in the southern highlands of
right, and it's a couple of miles deep. So he caught it at just the right time, and I just thought this was a lovely photograph.
The sun in that image has got to be just about setting there. You can see it's right on the Terminator.
Actually, it's just about
the shadows
just rising.
Oh, maybe, yeah.
Yeah,
Okay.
this is just
that would be sunrise.
Right around
okay. I'll buy that.
Yeah, this would be right around first quarter. So the sun is rising over Clavius.
The shadows are quite long.
So I found this striking. I'm not 100% certain that he took this like really recently, but it's certainly the first time I've seen this photograph, and I thought I would share it tonight.
It's a great photo.
Yeah, the other thing I wanted to, I have to get back to my Zoom screen now. Hold on here. If I can figure that out.
Unchat. I mean,
Yeah, there we go. That's what
unshare.
I wanted to do. Unshare. That's what I was looking for. Other thing I wanted to talk about was, since we're on the topic of planets and near solar system objects, I'm going to share this photo. At dusk, starting tomorrow, actually, you probably could have seen it tonight too. We have Mercury and Venus visible just after sunset. And the important thing that I'm saying here is just after sunset. Don't try looking for these two planets when the sun is still visible, because if you're pointing binoculars in the direction of the sun, you might actually get a surprise. It's just a blast of high energy light going into your eyes, and you can do damage to your vision. So you wait for the sun to go down, and then immediately looking right at the horizon. In fact, you have to first look for the horses. And then it'll be right. Anyway, I'm kidding. If you go up to like the Berkeley Hills, if you're here in Oakland and you go to like Inspiration Point or up on Skyline Boulevard, that's a great place to try to catch Mercury and Venus. And to give you some sense of how quickly things change, just 5 days later, you'll be able to see that there's a significant increase in distance between Mercury and Venus. And Mercury has a very, very fast orbit around the sun, and it'll be close to its maximum elongation around the 30th. Maybe it goes a little bit higher than that. So it'll be Venus, Mercury, and then if you're lucky, you might even catch the Pleiades if you've got enough resolution in the binoculars you are using. And that's it for what to look for in the sky in the coming week.
Hey, Richard,
Yeah?
I wanted to share an image here where you talked about Clavius and you showed the image, but I wanted to kind of share an image here showing where Clavius is on.
Yeah, I was having a hard time finding something that demonstrated that. I'm glad you thought of that. Thanks.
So this is looking at the southern half of the moon. Here's they're all labeled here. So this Moray, Nubium, and so on. This is Clavius right down here. This is the crater Tycho, which is the one that produces those big long rays that you can see when you look at the moon with a pair of binoculars. And just below Tycho, here is the crater Clavius. So his image, I think, is actually an inverted image of Clavius. So
yeah, that could be due to the type of telescope he uses.
Right.
I know he tends to prefer a Cassegrain, so things will be flipped. So yeah, I think you're right. Mario had commented, I wonder how much planning goes into such a phenomenal picture of Clavius. Well, Damien's methodology is not taking individual snaps with like a CCD camera. What he does is video. He's a master of using video for astronomy, and what he does is locates himself in very ideal locations around the Earth. I think he's preferring these days like the Bahamas and places where you have what's called laminar airflow, where there isn't mountains, there isn't a lot of disruption in the atmosphere due to geological features. So you go to a very flat island somewhere in the middle of the ocean, and you take your telescope and you attach a video camera to it, and you start shooting video. And at that point, you've got a collection of all of these video frames, right? And you go through them literally one by one and pick out the best frames from your video sequence and then stack them and process them as you would any other astro image. And his technique in doing the video acquisition, as well as his technique in post-processing, is above and beyond most people's knowledge, capability,
certainly
or patience.
Mine.
Yeah, it's certainly the patience part. So anyway, that's his methodology.
the thing that always makes me so jealous is he's got the same telescope that I have,
Yeah,
the same,
I know.
the same mount, and I
Yeah,
look at it,
yeah.
how did he do that?
It's so true.
Yeah. So anyway,
Yeah,
uh,
Bob was mentioning something I was thinking about this morning. Famous moments for Clavius in science fiction.
oh yeah,
Yeah, right. So the base located at Clavius Crater is featured in both the 1968 novel and 1968 film versions of 2001: A Space Odyssey. That wonderful scene where they approach Clavius and the docking bay opens up like a what would it? It's not like an iris. It's like a fan of metal plates.
it's like
Yeah.
the shutters on an observatory.
There, kind of like the shutters of an observatory. There you go.
And of course, the Tycho anomaly, I showed you how the Tycho crater is just north of Clavius. The Tycho anomaly, which was the obelisk or whatever you want to call it, monolith, obelisk, was in the crater Tycho. So they had to travel north to the Tycho crater to see what is it called? The monolith or
The monolith.
Yeah,
It was the monolith. And unlike the monoliths that were appearing all over Earth last year, that one wasn't a hoax. That was... All right.
I wonder whatever happened with that story.
Yeah, it kind of ended. They were popping up all over the world, and then I guess people got tired of it.
They got tired of making new monoliths and
everybody looked at them from every which direction, and nobody said, "My God, it's full of stars."
Well, stars, right? All right, what else have we got, if anything? How are we doing here? Let's see what I got.
Well, we had a meteor shower a couple of days ago. Not much of one. It was the Lyrid meteor shower, which is one of your less active meteor showers. And unfortunately, the weather wasn't very cooperative here in the Bay Area. And but it's the result of a comet that orbits around the sun and left behind a stream of particles. And every year, about the same time, and starting around April 15th and through the end of April, the Earth passes through that stream of particles, and it hits the maximum right around the 22nd of April. And so that's the Lyrid meteor shower. But again, it's not a really active one. You might see 20 meteors in the course of an hour if you're in a really dark location.
Well, the other thing coming up is next month we have a lunar eclipse and a special program here at Chabot. Of course, I can never remember dates or times, so Gerald, I'm counting on you to remember.
26th, very early in the morning on May 26th, and I mean really early in the morning. It starts at 1:47, I believe it is when it first starts entering the Earth's shadow. A lunar eclipse occurs when the sun, the earth, and the moon all line up so that the moon passes through the shadow of the earth. And the shadow has got two components to it. The outer part of the shadow, which is the much fainter shadow we call the penumbra. And then the inner part, which is a much darker shadow and has a reddish hue to it, that's called the umbra. And so the moon will be passing through the shadow. It will actually enter the umbra and only stay in the umbra for a very short period of time. It's crossing just across the very top part of the umbra. So it's only going to be in the umbra for a very short period of time. But this is going to happen very, very early in the morning of May 26th. We do plan to view that from Chabot using a telescope, and we may actually do it with a couple of telescopes, and we'll put cameras on them and let you watch it, weather permitting, obviously. And so
who's bringing the coffee?
I bet you Eric will have some coffee.
Yeah. Okay. Good. Somebody had better.
We're gonna have a couple of large pots of coffee, I think. So. And the hard part for me is I will have just come back from the East Coast the day before. So
you're going to be a wreck.
It's going to be rough.
Man.
Yeah. So anyway, so that's something to look forward to in May. All right.
Yeah.
So we're kind of winging it tonight, folks, because we've got
If
bad
you
weather.
If you can't tell, yeah.
We've got bad weather up here at the Chabot Space and Science Center, so we can let you look at the telescope, but we can't let you look through the telescope tonight. So yeah, there it is. And this is, of course, our 36-inch telescope. It's our largest diameter telescope here at Chabot Space and Science Center. It's a reflecting telescope, so it uses mirrors instead of lenses. It's also our only computer-controlled telescope, which makes it very nice for doing virtual telescope programs like this. And ordinarily, we would have a camera mounted on the back end of the telescope, and we'd let you see what we're looking at with the telescope. But tonight, we've got the roof closed.
So if I remember correctly, the mirror for this telescope, the 36-inch diameter mirror, it came from Lawrence Livermore Lab, correct?
That's correct. Yeah, it was actually purchased by them for one of their nuclear programs. However, I guess the program got canceled, or it turned out they didn't need it. I wasn't ever quite clear on what the story was, but the mirror never got used.
So we didn't have to check it with a Geiger counter or anything like that.
Well, what happened was, and I know Bob Schock is on here, and he may actually be able to help us with this a little bit. The mirror came to us, but it wasn't figured correctly for this size telescope. So I believe they took it up to Tinsley Labs, where Bob Schock used to work, and had to refigure it. But what happened was, Lawrence Livermore had the mirror sitting in a warehouse in a box, and the telescope was originally being designed for a 1 meter mirror. But, the mirror is one of the most expensive parts of the telescope. And somehow or other, the engineer who was designing the telescope and somebody at Lawrence Livermore got connected together, and they said, we got this mirror sitting here. It's brand new. It's never been used. It's yours if you want it. So we said yes. So it was not too difficult to reconfigure the telescope to take a 36-inch mirror.
Yeah, I mean, telescopes are typically built around the optics that you come up with. So, a lot of people, they'll see it, they don't realize that it's built around that mirror. We got that mirror, so what kind of telescope can we make for that mirror? And after it was refigured, the aluminum coating was put on by Lick Observatory. Is that right?
Yeah, it was originally done there. They had a problem. After you aluminize the surface, you put a clear coat over the surface to protect the aluminum. And apparently, the clear coat process did not work correctly the first time they aluminized it. So within just a couple of years, the aluminum coating on the mirror was starting to deteriorate.
I remember that. Yeah.
In fact, it got to the point where we were joking that we had the largest 8-inch telescope in the world because the image quality had deteriorated so much that it was about the equivalent of an 8-inch telescope. So then we took the mirror back out, took it down to UC Santa Cruz, and they redid it, and they put the correct coating on it, and it's been working well ever since.
And interestingly enough, there were 2 mirrors. There was actually a second one at Lawrence, and I don't know whatever happened to the second one, but it may still be around somewhere. But there were 2 of them.
Wasn't by any chance 70 inches, was it?
No, that's a whole other story. I'll save that for another night. Yeah, that'll be a whole other story.
Yeah, I know Bob Schock's on here. I think he was involved in refiguring it at
I think
Tinsley,
so too. Yeah.
'cause I know he worked there at the time, so maybe he can jump in here and comment on this.
Yeah, we have a whole bunch of other questions here. I'm not sure where to start. John, what do you think?
I got to get back to Facebook. I was looking at
you were looking at the YouTubers.
Yep.
Well, Michelle asked
about an orbital telescope here. There's a question. Yeah, there's the James Webb Space Telescope is going to launch later on this year. James Webb Space Telescope. and by the way, the optics was done at Tinsley Labs also. James Webb Space Telescope is an infrared telescope. So whereas our telescope here is designed to work in the visible spectrum, as is the Hubble Space Telescope. Hubble can go a little bit into the infrared range, but the James Webb Space Telescope is being designed to look primarily in the infrared. And it will launch later on this year. And that should give us some really spectacular images. Couple interesting things about it. It has 18, I believe it is, individual segments that form the total mirror. It's going to orbit at a Lagrange point, which is a point where the Earth's gravity and the sun's gravity are in balance. And that's a point that's almost 1,000,000 miles away from the Earth. So it's going to be pretty far away from the Earth, and it's going to be oriented so that a giant sun shield, it's about the size of a tennis court, will protect the telescope from the sun.
Well, we have a skeptic. Tim Thompson chimed in, and of course, Tim is somebody who is usually right about everything. He's one of those guys. So he says, James Webb Space Telescope, I'll believe it when it happens.
Well,
so
there have been so many delays.
I know.
Yeah, I think it was originally supposed to launch in 2011 or 2013 or something like that. And it kept getting delayed and costing more and more. And several times Congress was threatening NASA that they were going to cancel the program.
Yeah, I think it's getting close though. I feel that there's light at the end of the tunnel, so to speak, and they've really gotten past all of the engineering stuff, and they're now just like trying to wrap it up. But if you know how it is with any project, the last 5% takes 95% of the time. I think that there's a lot of that going on.
So is that why these little progress bars on the computer always stop at 99?
That is exactly right. And sometimes they stop at 100, and you still have to wait another 45 minutes. Here's a good question. Well, they're all good questions. All of you are asking great questions tonight. How good were the telescopes in the 1700s? My quick answer to that is they were pretty terrible, but they were also pretty new innovations. In the 1700s, they were still working mostly with single lens telescopes, and until Kepler came along and with designs and with achromat designs where you had multiple lenses, you had terrible aberrations in the telescopes, and also people weren't that good yet on figuring lenses with any degree of precision. It was only until the science had evolved, until Newton tried his hand at it, and until Newton actually came up with the reflecting telescope, were we able to have larger aperture instruments with higher degrees of precision. And so really it wasn't until the 1800s that telescopes started to become really good.
So Sana asks, and I believe she's talking about Nellie at this point. What's the optical design and aperture of the telescope? What does that happen to be? It is a classic Cassegrain 36-inch, and it's an f8. And she also wants to know the field of view with the CCD that we typically use, I guess.
Very narrow.
Actually, we use different.
Yeah, I think
we use different cameras.
It's somewhere around 16 or 18 minutes of arc, which is less than 1 degree of arc. So not very much.
Yeah. I mean, I'll try to bring up while you're talking about that. I'll try to find an image that demonstrates the field of view.
Yeah. So basically, when we point the telescope at the moon, when we're looking at it, when we've got the camera on it, we don't even see half the diameter of the moon. We see less than half the diameter of the moon.
There's
another good question.
30 minutes wide. Yeah, the moon's about.
Here, let me share an image that kind of people are very familiar with the Orion Nebula, and and what the trapezium looks like in a typical telescope.
At least we hope they're familiar with it by now,
Well,
after all of the
after all the
photographs
times
that
we've
shown
it, yeah. But even if you never looked at our program before, it sounds like the person who asked the question was familiar with astronomy.
Yeah.
So this is the shot we were showing people of the Orion Nebula taken through Nellie with a standard DSLR camera, not even a full frame. It was an APS-C, smaller sensor camera, and the trapezium is right here where my cursor is, and it kind of gives you a sense of what the field of view is through this telescope. It's quite narrow, and it presents significant challenges to doing photography. But it also is a significant opportunity because most instruments that we get to use as amateur astronomers don't have such a narrow field of view with this kind of magnification. So it's a lot of fun to work with. It's very different.
Yeah. Hey, Bob Schock is chiming in here. He says he was not working at Tinsley at the time that Tinsley reworked the mirror. He did note that when Lick coated the mirror the first time, it was the first time that they had ever done a clear coat on top of the aluminized surface. He says that when Lick aluminizes mirrors for their own telescopes, they don't put the clear coat on. So this was their first attempt at doing that, and obviously it didn't work out too well. But that's okay because we got it taken care of at UC Santa Cruz, which actually is associated with Lick.
Yeah.
And then he also noted something else. He noted that there's a company called DFM Engineering, and they actually did the control system, helped Denny or Kevin Medlock with the mount, and they did the control system. So when you see the control system that we use, I'll kind of turn my laptop here. You can see the computer software here. That control system was designed by a company called DFM Engineering in Colorado. And that's what we use to control the telescope. And somebody asked it whether we use Fresnel lenses on telescopes. Why would we do that?
That would make things kind of distorted, I think.
Yeah. Fresnel lenses are designed to kind of redirect light so that you get a nice beam. So like, there's Fresnel type lenses are on
lighthouses
and things like that. But they would actually not be good at all on a telescope.
Yeah, it wouldn't be contributing to magnification at all,
right?
For the types of sensors that we put on, even our eyepieces. Somebody was asking if it's possible to see the SpaceX capsules through a telescope, and the answer is yes. Yeah. But not through a telescope like this, really. It's even though theoretically we could, you actually need to be able to have a telescope that can track the apparent motion of the International Space Station as it flies overhead. And if you've ever seen the ISS fly overhead, it's going at a pretty good clip. And we're not about to take a telescope like this and try to change its slew rate to match the space station. But there are people who have rigged their telescopes to do just that, and they take video again. It's like the Damian Peach thing I was describing earlier. The people who are able to photograph the space station in exquisite detail from the ground are doing high-speed video through a telescope that is slewing as close to the same rate as the ISS as they can, or they have mastered moving it by hand at the right rate to capture the video, and then they pick out the individual frames once again and put them together in order to get that detail. And I have seen more than one example of the space station, all of its modules, and either an approaching or docked capsule to it from people who have mastered that technique. It's not easy.
Yeah, we could do it with this telescope if we knew the orbital elements. We would have to then calculate the rate of right ascension and declination motion. Have to plug that in. Then we'd have to find it and stay with it. We could only stay with it for a very short period of time. So
It would be really hard.
Yeah.
it's really not worth it.
We'd break something.
And it pretty much changes. Changes with every pass that they make.
Exactly
so
right. Yeah.
You don't get a second chance, really.
Hey, Richard, you were mentioning something a while ago about chromatic aberration, and I wanted to kind of share an image.
Oh, please. Yeah, I'm sorry. I went ahead and I threw out that term, and I'm realizing, probably nobody knows what I'm talking about.
So I'm gonna share an image here. This is an image of the Dumbbell Nebula, which was taken with one of our other telescopes here at Chabot, one of our older refracting telescopes. And if you look at the stars, you see that they all have these kind of halos around them. And that is called chromatic aberration. When you pass light through a lens, you're bending the light to bring it to a focus at the back end of the telescope. And when you bend light through glass, you create a little bit of a prism effect. It actually separates the colors. And because of that, the colors cannot all come to a focus at the same point at the back end of the telescope. So what we tend to do is focus the telescope based on the wavelength of light that our eyes best perceive. That wavelength is sort of around the kind of the greenish yellow part of the rainbow. And when you do that, that part is in focus. But the two opposite ends of the spectrum, the blue end, which is the violet end, I guess you call it, and the red end, they're out of focus. And that creates this sort of purple halo that you see around bright stars. That happens with refractor telescopes, especially older refracting telescopes. And it's one of the things that you get rid of when you use a mirror instead of a lens type telescope.
The other way to get rid of it is to use what's called an apochromatic lens system, where you're actually putting a third element in the lens stack to specifically correct the blue light, so it comes to a focus at the same point as the other parts of the spectrum. And those tend to be expensive, right? It's a great innovation, but it's an expensive innovation.
Also, they do a great job, but they're still not complete. There's still always some degree of apparition there.
Well, they tweak it with the coatings that they put on the glass, so you get it as close as possible. With you do the ray tracing as close as possible with the glass elements, and then you can tweak it with different types of coatings on the glass to get that refraction just right. They get as close as they can. It's pretty amazing. It's certainly a lot better than what we would have seen in the 1700s, though. Even the one with even that Dumbbell Nebula, that there might be chromatic aberration around those stars, but that's very little compared to what they were contending with early telescopes. A really good question. Two really good questions here that I see. One has to do with Chabot. How many telescopes do we have? Well, we have a basement full of them. We have more than I can count. But in terms of our main telescopes, we have three main telescopes here at Chabot. The 36-inch behind us, and there is a 20-inch refractor telescope, one of those really long classical refractors built in the early 1900s. It's a 20-inch diameter instrument, and she is named Rachel. And we have an 8-inch refractor telescope manufactured by Alvin Clark and Sons in the late 1800s. Named Leia, and they're all fantastic instruments. Related to that question was another one that says, well, are the telescopes swapped out on these mounts? The answer is no. Telescope is generally married to the mount and stays there all the time. This is not a lightweight instrument by any means. There would be really no way to swap out the instrument without it being a big production and a one-time thing. So it is what you see, and it stays that way.
Hey, Richard, somebody asked what it was that we were looking at just now. I assume they're talking about the dumbbell.
Probably the dumbbell. Yeah, why don't you
yeah,
back up?
Let me show that again.
Explain what it is.
Yeah, so this is called the Dumbbell Nebula. It's one of many clouds of gas and dust out there we call planetary nebulas, and they have nothing to do with planets. A long time ago, astronomers thought when they first saw these faint little fuzzy objects, they thought they were actually planets in the process of forming. But later on, we realized they're actually stars in the process of dying. So this is a planetary nebula right at the center. It's kind of hard to make out here. There's a white dwarf. It's all that's left of a star that was once similar in size to our sun. And that star grew old. It swelled up when it grew old, and then it lost its outer layers of gas over tens of thousands of years, exposing the inner part of the star. Eventually, the star collapsed, became a white dwarf, and it's surrounded by all that gas that was expelled by the star. The white dwarf emits ultraviolet radiation, which ionizes the gas and causes it to glow. So this one is called the Dumbbell Nebula. It's, I forget which constellation it's in. It's near Cygnus, but I think it's...
Yeah, it's just outside of Cygnus.
Sagitta. Is it Sagitta or is it
It might be Vulpecula.
Yeah, I think you're right. I think it's Vulpecula. Yeah.
Yeah.
So...
Did Conrad take this photo?
Yeah, he took it through Leia.
Yeah.
Our 8-inch telescope.
So this is this is a photo by Conrad Young, who is a longtime astronomer here at the Chabot Space and Science Center. I'd say lifetime astronomer here at the Chabot Space and Science Center, and previously the Chabot Observatory. And this is one of my favorite photographs of the Dumbbell Nebula. It shows so much detail, and it's all in just red, green, blue. It's not doing any of the narrow band tricks that that we often use to bring out some of the colors and details. It really gives a great sense of what it looks like, not only to the eye but also magnified. And anyway, I just love this photograph.
One of the great things about it is it was taken through our 8-inch refractor, with the one we call Leia, which was built in 1883 by Alvin Clark and Sons. And that telescope is still working. We still use it regularly here at Chabot Space and Science Center. And when we reopen, come November, you'll get a chance to come up and view through that telescope plus our other observatory telescopes.
Yeah, that's the great thing about telescopes. Unlike refrigerators, they last for a very long time.
There's a story behind that.
There's always a story behind whenever I say the word refrigerator.
I can come up with a few myself.
Yeah.
Sean asks, where are the darkest skies close to the Bay Area? Unfortunately, that's almost impossible.
I have a suggestion.
Those two terms are mutually exclusive.
Right. No. I have a suggestion for her, though. You mentioned that you're in Sonoma County, and one of the best places to go in Sonoma County for dark sky observing is Lake Sonoma. And it's far enough away from the Santa Rosa light dome that you could actually do some very good dark sky observing there. So break out your map, take a look at Lake Sonoma. I believe the park has reopened from COVID, and it's a great spot not too far from you.
Hey, there's a couple of interesting questions here on YouTube. One question. My 7-year-old son, Langston, is back and wants to know how many days would it take to get to Andromeda? And can we see it through the telescope?
How many days?
Yeah, Andromeda is roughly 2.5 million light years away. So if you traveled at the speed of light, you would take 2.5 million years to get there, but because of the laws of physics, you can't travel at the speed of light. You
How
have to
about a brisk walk?
it's a little bit slower than that.
Yeah.
So, Langston, the answer is too long for you.
Too long for any of us.
Yeah. So, but that's how far away it is. 2.5 million light years away, which means light from Andromeda Galaxy takes 2.5 million years to reach us. But I do have some good news for you. The Earth, I mean the Milky Way galaxy, our galaxy, and the Andromeda galaxy are moving toward each other. In fact, they're moving toward each other pretty fast, about 300 kilometers per second. So they are getting closer and closer to each other. And if you want to hang around for about 2 billion years, the two galaxies are going to start merging. So, you don't have to walk there. You can just
You could just
hang around,
watch. Yeah.
just lay here and
Yeah.
watch.
Just hang out on the couch and watch it happen. That's right.
Yeah.
Even at its maximum speeds that we can achieve today, the closest star to the sun would take us decades to reach. So another galaxy is really a way out there.
So, unless somebody invents a really good version of warp drive, I
Right.
think we're not going to the Andromeda Galaxy for a while. So, let's see. Somebody else asks, do you have any plans to loan or donate your surplus telescopes?
Well, let me respond to that. So, well, there's a couple of options there. We're every once in a while we do give away telescopes that we don't find use for here anymore. But we also have a society here called the East Bay Astronomical Society, and once things get back to normal, we have what's called a loaner scope program, and it's possible for members of the EAS to check out telescopes for a month or two, and use them wherever you wish. We would be also open to the idea of making them available to schools. So it's the kind of thing where maybe when we're not locking ourselves up indoors and we can maybe get back to having programs and actually see people and exchange goods with one another, we should revisit that discussion, and because it should be available to you.
So Jasper asks, I hear the merger, I assume we're talking about Milky Way and Andromeda. I hear the merger will mean no more spiral structure, but why? Well,
what a great observation.
Because the two are not at the same angle to each other. They're going to slice into each other, and it's going to be completely disruptive. I mean, it will just be a complete mess for a while because the mutual gravitation of the two galaxies and all the stars within them, it's just going to be chaos for a while. And when it comes back together, when it finally results in a merged galaxy, it will be more like an elliptical galaxy rather than a spiral galaxy because of all of the forces involved and all the different motions involved. Instead of giving us a spiral galaxy, we'll have an elliptical galaxy. And that's not unusual. There are a lot of elliptical galaxies out there, and it's likely that some of them at least were produced by mergers, such as what's going to happen with Milky Way and Andromeda.
That's interesting. Will there be enough rotation so that eventually it will go back to a spiral form?
I don't think so. I don't think that's going to happen. I think once it's an elliptical, it's going to stay elliptical, and eventually
will be categorized in some other part of the universe or some other galaxy as an ARP peculiar galaxy. There is a catalog of galaxies called the ARP galaxies, which are mostly galaxies that have undergone some kind of very disruptive collision. And ARP was an astronomer, and he cataloged these things, and it's a very interesting catalog to look through. And we're going to become one of them.
Yeah, we actually have an animation in our planetarium that shows what happens when the two galaxies collide. So maybe after Chabot reopens, we'll get a chance to get you up here and let you see that. It's something where somebody sat down and did the math and individually plotted all the stars and how they will react to the mutual gravitation and everything.
I'm pretty sure there's a pretty good website that has.
Yeah, I'm sure there is.
There's Andromeda, AndromedaCollision.com.
I want to give people.
Just search for it; it's there.
Yeah, I want to give people an excuse to come back to Chabot, though.
Right?
Yeah, we got to keep doing
Absolutely.
that.
Yeah.
Well, we've gone through a whole hour. We did really pretty well for winging it. I got to say something though. We had really great questions tonight, and our ability to do a reasonably engaging program tonight is because of your questions. So come back next week and visit us, because we're only as good as our audience is, and really appreciate the thought that went into some of these questions and comments tonight.
Yeah.
All right. Okay. Well, once again, we want to encourage everybody to donate to help us out. There's a donate button on the Facebook page. If you don't have access to that, you can go to the Chabot website, which is chabotspace.org, and you'll see a donate button at the top of the web page there. We do rely on those donations while we're closed. We need those donations to help fund our continuing programs, to keep our staff employed. So any help you can give us would really be appreciated.
All right. Well, good night, all.
All right.
Enjoy the rest of your weekend.